It's been quite a while since I repaired this PowerBright 1500 watt Pure Sine inverter. The 2200 watt inverter, Pure Sine inverter, has not been repaired yet. I still need to order that one part, and I haven't done so because I am waiting to see if this one works. If it doesn't work and has other problems, I may need to address those problems on the other unit first. But anyway, so it's another day. I have a little bit of time, and I'm going to see if I can fill my house with smoke once again. Hopefully not, but it certainly wouldn't be the first time. And I am kind of tired, so I'm going to get some inverter fuel going here. Sure, I could just sleep, but you know what they say. Sleep is for the weak, or the well-rested. I forget which. Anyway, I'm going to set this up and let's get going. About 5 minutes and a proper amount of caffeination later, my test setup is here. It is pretty basic. I just have a battery connected up to the inverter terminals through a amp meter, and I have my multimeter here that should be plugged into the output in this power strip in the kilowatt meter, and I just have my standard electric heater as my load once again, like always. And to be frank, I don't really remember where I left off on this inverter, so I'm just going to go for broke, turn it on. This is a 1500 watt inverter, supposedly. This is a 1500 watt heater, supposedly. So they should be a good match. Let's see what happens. Inverter is on. We have 113 volts out. Input current jumps around a bit, but that's pretty normal. Everything looks good. Just to verify, is it a sine wave? Yeah, indeed it is. Alright. Heater on low. We're drawing 500 watts, 50 amps. Nice clean sine wave. Next. Heater on medium, 80 amps. Nice clean sine wave. 800 watts. Heater on high, 1200 watts. Nice clean sine wave, 134 amps. Now I think it is beeping. I'm going to turn this heater off for a moment. I think it is beeping simply because the input voltage is too low. Please excuse the shaky camera work here. This is just a quick video. Turn the heater back on high. It's now set to DC. Let's see what my input voltage is quick. If I can do this one-handed. 11 volts, and it's complaining at me. That makes sense. So let's see if I can rectify the low voltage condition here, and then we'll test it again. Alright, I put my DLS45, my 45 amp battery charger, onto my battery, just to give it a little bit of a boost. I really should have more than one battery here, but I got lazy today and just hooked up one. It's a 1500 watt inverter, and my rule of thumb is you need one battery per 1000 watts. So this really isn't adequate, and I can't blame the inverter. That is my fault. So let's try this one more time with the 45 amp boost on it, and we'll see if that improves the situation. Heater's on medium, heater's on high, and it is not complaining. If I go to volts, hit the right button, 112 volts, so it really didn't sag. That's good to know. And just out of curiosity, my input voltage is, once again, please excuse the shaky camera work. Input voltage is 11.3. So apparently at 11 volts, it complains about low voltage. And that's to be expected. So 129 amps at 11 volts, 1200 watts out. So that's a pretty efficient inverter. Let me quick do some calculations here on 1220 watts out, 129 amps in, and 11.3 volts. I'll just quick calculate that out and we'll see what the efficiency is here. Given the information that I just told you, anybody with a calculator can calculate the efficiency. However, through the magic of editing, I'll save you all the effort. It's about 84%. And 84% when an inverter like this is loaded to 70% of its rated capacity or so is on the low side. It's not terrible, but it's not all that great either. I expected it to be a little bit higher. Anyway, at least it does output that much, which is good without sagging in voltage, even though I only have one battery here when I should have two. So that's not too bad, but it is a 1500 watt inverter, so let's do a test to see if it can actually do 1500 watts. Now, the good news so far in this test is that this inverter has not started on fire or smoked or anything like that, so I do believe that I have it repaired. We'll do some sort of stress test here after a while, but for now I'll just continue with what I'm doing. I'll turn the inverter back on. We have 113 volts. Good, good. I'll turn the heater on high. You can see that the voltage was nice and steady. Turn it off. The voltage didn't change much. So I like to do this test here. I turned on a 100 watt light bulb over here in my light bar, and let's see how well this inverter regulates the voltage. This is just a visual test since I don't have an oscilloscope or something to hook up to do this. So if I have that light bulb on and I turn on the heater, the light doesn't flicker whatsoever. It is perfectly solid, and that is dang impressive. I did not expect that. The only other inverter that I've ever had that is solid like that, very well regulated clean power, are the Samlex inverters. Apparently PowerBright did a pretty darn good job, and that is impressive. Congrats, PowerBright. I didn't expect that given the construction quality inside these things, but it apparently functions pretty well. So let's move on here. I am going to take my multimeter, jam it in the outlets in the safest fashion possible. Come on. If I can get them to seat in there. Turn this in AC voltage, somewhere where we can see it. There we go. Put this on watts. So now we have watts in AC voltage. Turn my heater on high. These apparently came out of the outlets. There we go. That's better. So I have the heater on high, one light on, 1300 watts. 1400 watts. 1500 watts overloaded it, and it's complaining. So let's see if the inverter fried or if it's just overloaded. Turn the switch off, turn the switch on, and everything is once again happy. So this inverter does about 1500 watts, just like it's advertised. Certainly no complaints there. Let's test its surge capability. I'll turn on some lights here, 500 watts worth. Now as soon as I turn this heater on high, it'll be overloaded. Let's see how long it can sustain that overload before it shuts down. It's on medium. I'm going to turn it on high, and let's see how much time this takes. It's about 1/2 second. So this thing will surge for approximately 1/2 second. And that is about what I would expect in an inverter of this price range. The Samlex inverters surge for nearly 10 seconds, which is extremely good, but they do cost more, so I can't complain too much about an inverter that surges for 1/2 second. That's better than some of the cheapest ones do, and that is pretty typical for a mid-range inverter. So let's now check the actual surge performance of this. And for that, I'm going to get the setup ready that I always use. I'm down here in my basement, and for those of you who haven't seen many of my videos, this is my nasty old 1980s dehumidifier. This thing takes about 3500 watt startup surge when you plug it into an electrical outlet. It is very difficult to start. Lots of inverters have trouble with it. The good quality ones don't. So I'm going to plug this in to do my surge testing, just like I have in most of my other videos. It is a very good test to see what the quality of an inverter is in terms of its surge performance. So I'll plug this in, run back upstairs, and we'll see if it can start this dehumidifier. I have this 12 gauge 50-foot extension cord snaking all the way down to the basement, plugged into that dehumidifier, and there are two things that are likely to destroy a weak inverter. One of them is a severe overload, which is what's going to happen when I plug this in, and two is a long-term high power output test, which is likely to overheat something. Now, this is repaired. I have really not tested it yet, so this is the first stress test that might destroy it. Now, I'm going to do a couple of things here. One, this is my ammeter. I have it set to peak, so you can see the peak that it draws from my battery. This will give us a good idea of how much surge output it can really do, since I'm not going to be hooking up anything that can measure a peak surge on the output side. I'll do it on the input side instead. That's a pretty good way to do it. And second, I'm going to turn on one light bulb. And we're going to see, at least I can see it here, I don't know how well you can see it on camera, see how much this dims when I plug in the dehumidifier. And hopefully it can start it. We'll see. This is a 1500 watt inverter. The Tiger Claw 1500 watt inverter, which sells for probably about a third as much as this one, half to a third, can run my dehumidifier just fine. This one may or may not be able to. Some inverters can, some can't. It depends a lot on their construction quality and how well they're designed. So, this will hold the peak value, and I'll keep the camera over here so you can see this light slightly, and we'll see if it starts up, or if my inverter starts on fire, or what happens. Here goes. And it did start it up. The light dimmed, but not terribly. And, oops, I had it on AC amps. Sorry about that. Let's do this test one more time. Alright, sorry about that. This time I have it on DC amps. So we're going to see what kind of surge this inverter can do. It did start the dehumidifier, which is good. Well, yeah, that's good. So let's try this again. Try number 2. I'll plug it in and we'll see if we can start it a second time. And yes, it starts it just fine. The surge here is 172 amps, and that is disappointing. This is only one battery, which isn't really adequate for this type of surge, but a good inverter. For example, I've connected that Samlex 2000 watt inverter to this same battery, one battery just like this, and it draws more than 400 amps. That's over 4,000 watts of surge capability, and that is very impressive. This one does a soft start sort of technique where it lets the voltage sag, which is acceptable, and it did start that dehumidifier, which when plugged into an electrical outlet takes 3,500 watt surge. However, it can only output a little over 1,500 watts. It really has no surge capability at all. Very, very little. But its output power was quite clean. So let's try this one more time. My dehumidifier is running right now. If I unplug it, it will stop. And I'm going to plug this right back in again, and we'll do a locked rotor draw test on that dehumidifier. Perhaps it will be able to draw more current in a locked rotor condition, perhaps not. Either way, the inverter is going to overload and complain, but that's to be expected once again. So let's reset this, go to max, unplug my dehumidifier, and do a locked rotor draw test. Here goes. Nope. It was not capable of doing any more than before. Still about 180 amps. And there's the result for the surge capability. The OSP Tiger Claw 1500 watt inverter that I had has a lower efficiency than this, but a much higher surge capability than this. Output power quality was a little bit lower. It doesn't actually do 1500 watts like this one is able to do, but for what it costs, I would say it's a better value than this one. Now, one thing I've noticed on this inverter is that the fans have not yet turned on. They are temperature controlled, so that's not a problem. However, I want to make sure that they work before I say that this is fixed. And I also want to do a stress test to see how warm this thing gets. It is getting warm now. the outside case. And I'd like to stress it a little bit more than what I have. So what I'm going to do is turn it on and turn this heater on high. So we are now drawing just about full load out of it. 1300 watts or so. Can only do 1500. It's drawing 130, 140 amps. And I'm just going to let it run like this for a while and see what happens. And there it goes. It ran for about 5 minutes at nearly full load before the fans turned on. And the air coming out isn't particularly hot yet. The heat sinks in here are pretty massive, so I'm not too surprised that it took that long. They'll probably run for quite a while after I shut it off also. But the fans are somewhat noisy. They're not speed controlled, they're just on and off. And they just shut off again. Anyway, they are fairly noisy, but not unacceptably so. So everything on this inverter appears to work once again. So I have successfully repaired it. And this will, I think, suffice as a PowerBright, a 1500 watt sine wave inverter review. I forget the exact model number. Let's see if I can find that quick. Here's the box. Model APS 1500-12, 1500 watt continuous, which is correct. Surge capacity 3000 watts. It's complete BS, just like usual. But that's to be expected. A lot of inverters are that way. 12 volts, 115 volts, pure sine, 13 amps, blah 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 blah. I don't have a harmonic power analyzer on hand at the moment, so I can't tell you exactly how much distortion there is. But it is very clean, and I don't have any complaints about it. This inverter is actually better than I expected. So I'm going to let this run for another 15 minutes or so as a burn-in, just to make sure that everything is okay. The fans are turning on and off at this 1300 watt load, so that means that it is fully capable of cooling itself, even in a very warm environment. So that is a good thing to say. In summary, this PowerBright inverter has very clean output power. I am somewhat impressed with that. Its surge capability is pretty decent. I don't have any complaints about it. The efficiency is so-so. There's certainly better ones out there, but they cost more. And there's certainly lower ones out there too, but they cost less, so that's kind of up to you. Ames Power, for example, that was a very efficient inverter, the one that I reviewed. However, its performance was extremely poor, and I would not recommend it to anybody. I have a Samlex Go Power Thor. I think Kotek also makes the same thing, but inverter of a 2000 and 3000 watt output level. The 3000 watt ones are very, very nice. Very clean power, very high surge, very high efficiency. That's the most efficient inverter that I have now. Before that one, the most efficient inverter I had was a Moto Master Eliminator 3000 watt modified sine wave inverter. That Kotek, or the Samlex 3000 watt pure sine, that one actually is more efficient, and that's impressive to me. Anyway, this inverter, the main downside that I have is the construction quality. It is very, very poor. Big thumbs down on that one. And for that reason alone, I can't recommend this inverter to anybody. I certainly will not recommend you don't purchase it. However, I can't recommend it for that reason. If, especially on a vehicle or anything like that, it's very... What was that? I think my input voltage is getting too low for it. When the fans turned on, it actually pulled the input voltage down too much. Again, I only have one battery running here. So anyway, I would not recommend this for a vehicle application. However, in a stationary application, it might work out okay. But the construction quality inside is somewhat poor, so I'm not going to recommend it for that reason. But here it is. It works. It's fixed. It's a pretty decent inverter, really. And if you can get one for a good price, $350 or so, then sure, go ahead and pick one up. So that concludes the video on the 1500 watt inverter. The 2200 watt one is still pending. I have to buy that part, then I have to put the part in, and then I have to retest it. So I may or may not make a video on that again, but I wanted to quick show you this one as I tested it out. Since I'm going to do it anyway, I might as well make a video on it. And I am now finished with this inverter. Thanks for watching. This is a short addendum. I realized that I may not have been fair yesterday when I criticized the efficiency of this inverter. I only tested it at one point, and that was nearly full load. It was 84%, and that was maybe not quite fair of me. So I'm going to do another quick test here, just quickly, to show what the efficiency is at a lower output level. Now first I want to say that the no-load current draw is quite good on this inverter. It is below 1 amp, which is pretty good for a sine wave inverter. So what we're going to do is turn it on, set this to watts, and put a lighter load on it. So there we go. We've got around 500 watts coming out, and on these two meters I have this set to DC volts. We've got 12.76, 46.4, and 504 watts. Let me quick do the calcs. Well, that ended up being 85%. So this inverter is on the low side of efficiency. It doesn't reach the 90% that they advertise, but it is mediocre in terms of its efficiency. So 84% at high load and 85% at 500 watts. I just wanted to add that on to the end to be fair to this PowerBright inverter.